Hello, everybody. I'm Mirsad Salati. I'm currently pursuing a master's degree in artificial intelligence and robotics at University of Tehran. Over the past 2 years, I have gained experience in deep learning and natural language processing. I'm recording this video in order to participate as a teaching assistant in Neuromatch Academy. In this video, we are going to talk about Pytorch Autograd. Autograd is a Pytorch automatic differentiation engine. Automatic differentiation is a computational technique used in deep learning to automatically calculate the gradient of the neural network's parameters with respect to the loss function using chain rule of calculus. Autograd is useful because it simplifies the process of the training of deep neural network, which could have millions of parameters. Without Autograd, the manual calculation of the gradients would be extremely time-consuming and error-prone. Autograd automatically tracks the operations performed on the tensors during forward propagation and build computational graph. During backpropagation, the gradients propagate backward through the graph. In this exercise, we are going to build a simple computational graph. In Pytorch, a computational graph is a directed cyclic graph, or DAG, that represents the computations performed by a neural network. In this graph, nodes are representing the intermediate value and operations performed during forward propagation. And the edges are representing the dependency between. In this simple example, we are going to implement a computational graph of a single neuron with a scalar input x and a scalar output y. In this simple network, W and B, weight and bias of the neuron are our trainable parameters. The first important tips that you should consider is using required grads equal true when defining the tensor of the weights and bias, because they are our trainable parameters, and we need to calculate the gradients for them. For the forward pass of neural network, this simple neural network, we multiply input x by the weights of the neuron, and then add the bias, and at the end we apply tangent hyperbolic as activation function of the neuron. Let's code this. After finish implementation, we comment to raise exception code line. For loss function, we are using a squared error loss, or L2 loss, that is implemented by this line of the code. And again, comment the raise command. And at the end, we uncomment this part that use the previous ones. Now we can execute the cell and see the result.